Hello students, welcome you to another lecture of physics. This is Sir Murtaza from Al Murtaza School. So let's continue our chapter number 2 with some more SLOs. Okay, so here first we will look onto the agenda for this lecture video. What is the agenda for this video? The agenda for this video is we are going to discuss the following SLOs. The SLO is 2.7.1 in which we will be learning about describe the resolution of force into its perpendicular components. Okay, so we are continuously talking about forces because force is an easy example to understand about vectors. Okay, previously when we have talked about vector addition, so there also I have taken the example of forces. Okay, so as force is a vector quantity, whatever the rules forces used to obey, vectors also used to obey the same thing because force is a vector quantity. Okay, so just keeping it simple to make it understandable for you, I have taken the example of forces. So again in this SLO we will be talking about forces and we will be talking about the resolution of forces. Okay, so let's look on the definition first. Resolution of force. What is it? What is its definition? The definition is splitting up of a force into its mutually perpendicular components, that is x-axis and y-axis, is called the resolution of that force. Okay, so what is resolution of force? A splitting of a force. Okay, we have a force. If we split it, okay, if we split it into its mutually perpendicular components, which are x-axis and y-axis. Okay, x-axis and y-axis are also called as mutually perpendicular components, is called the resolution of force. Okay, in simple words you can just say that whenever you are splitting up a force, it means that you are talking about resolution of forces. And how we split it? We split it into its x component and y component, and these are called as the perpendicular components. Okay, so here we will look onto the explanation. I have a figure for you. Okay, this is a figure. I need you to concentrate on this figure and have a good focus on it. So here, this is x-axis. Okay, we have mentioned it, and this is y-axis. So what I have done is, uh, I have drawn a force this like this. Okay, this is a force F. Okay, which has been inclined at some angle with the x-axis theta. Okay, here the theta has been shown. Now what I have done, according to the definition of resolution of forces, I have to split this force into its mutually perpendicular components. So what I have done, I have split it into its x component, which I have set as fx. Okay, and this line OB represents the line fx. Okay, and the second force is Fy, which is its component along y-axis. So this is Fy, and it is represented by the line AB. Okay, so what I have done, I have split the force F into Fx and Fy. Okay, and this Fx and Fy is represented by the line OB and AB. Okay, now consider force F represented by line OA making an angle theta with the x-axis as shown in figure. Okay, so what I have done, I have taken a force F which is represented by a line OA. This is the line OA. This is O and this is A. The force F is represented by OA making an angle theta with x-axis as shown in figure, and it is making an angle theta. What is theta? Whenever you are talking about angles, so you represent it by a symbol which is called as theta. Okay, so it is called as theta. I may write it for you. Okay, whenever you are talking about angles, so angle is represented by theta. Like force is represented by capital F. Okay, for example, if you are talking about mass, it is represented by M. In the same way, whenever you're talking about angle, it is represented by theta. Okay, so this is theta for you. Now draw a perpendicular AB on x-axis from A. What I have done, I have drawn a perpendicular AB on x-axis. Okay, I have drawn a line AB on x-axis, and this is line AB. Now according to head to tail rule, what we have learned in our previous lecture, OA, now this line OA, what is it? It is a resultant of the vectors represented by OB and BA. Okay, so here you can see there are two vectors, OB, this is the head of first vector, and AB, this is the tail of second vector. Both these vectors are added by head to tail rule. So these are added by head to tail rule, and the tail of the last vector is joined with the head of the first vector. Sorry, the tail of the first vector is joined with the head of the last vector. So this is the resultant force. Okay, and one thing I have to say you that the resultant force F is represented by Fx plus Fy. Okay, this is F, and also keep in mind this small x is in its subscript. Okay, plus this is Fy, F and y. This y is again in its subscript. Okay, now let's move forward. Now here I have to move this. Thus you could say that OA is equal to OB plus BA, because OA represents the force F, OB represents what? It represents Fy, and BA, sorry, it represents Fx, and this represents Fy. Okay, I could show you again in this figure. Just remember this. OA represents F, OB represents Fx, and AB represents what? Fy. Okay, so you could say that O is equal to OB plus BA. You could say it as equation number 1. Then, thus the component OB and B are perpendicular to each other. They are called the perpendicular components of OA representing force F. Okay. Then OB and B are perpendicular components, and of which perpendicular components of the force F, which is represented by OA as I have shown in the previous diagram. Then thus OB represents its x component Fx, and B represents its y component Fy. Okay. Therefore, equation 1 can be written as F is equal to Fx plus Fy. Okay, as I have told before, the equation 1 can be written as F is equal to Fx plus Fy. We can say it as equation 2. Now, in right angle triangle OAB. Okay, before talking about a right angle triangle, just wait for a moment. I wanted to tell you something. In maths, you have learned about trigonometric ratios. Okay, hopefully you have learned about trigonometric ratios. So whenever you are talking about a right angle triangle, you are dealing with trigonometric ratios. What are trigonometric ratios? Trigonometric ratios are sine theta, cos theta, and tangent theta. Okay, there are also some more sec, cosec, and cot, but we will be talking about sine and cosine. Okay, sine, cosine, and tangent. So basically, trigonometric ratios, whenever you're talking about trigonometry, trigonometry means the study of three-sided shape. So you have to be defined, you have to have some ratios. So these ratios are called trigonometric ratios, and trigonometric ratios basically describe the ratio of the sides of a right angle triangle. Okay, for example, this is a right angle triangle. Okay, this is a right angle triangle. So in a right angle triangle, as it is a special type of triangle in which one side is of 90 degree, this is of 90 degree. So its side is being named with some special names. Okay, this side, which is the longest side, is known as the hypotenuse. I am writing it as HYP. This is called as the hypotenuse. This line is the perpendicular, PE RP. I'm representing it as PERP. This is perpendicular, and this line is the base. Okay, so for a right angle triangle, the sides is being named with some special names, which is perpendicular, hypotenuse, and base. Okay, so this is the name for the sides of a right angle triangle, and those ratios that define its sides. Okay, the ratios of its side are called trigonometric ratios. So here you have to remember one thing: in right angle triangle OAB, cos theta is equal to base upon hypotenuse. Okay, so what does cos theta defines? It defines the ratio between base upon hypotenuse. This side is base and this side is hypotenuse. Okay, so in the right angle triangle, then we can write it as Fx upon F. Okay, for your convenience, I'm drawing this figure again here. Okay, so in this figure, what I have done is this force is represented by F. This was represented by Fy. Okay, and this was represented by Fx. Okay, so according to this figure, what is the base? Base is Fx. Okay, this is the base. And what is hypotenuse? This is hypotenuse, which is F. Okay, so we can write base as Fx and hypotenuse as F. And as I have to find the value of Fx, so Fx is equal to F cos theta. Okay, this is a formula which we have to remember for vector forces, okay, which is Fx is equal to F cos theta. Okay, how we have derived it? We have derived it in the manner that I have shown you. Okay, now again, okay, what is right angle triangle OAB? I, for your convenience, I think I should show you this diagram again. Just keep remember this. Please keep remember this. This is a right angle triangle for you. Okay, this is O, this is A, this is B. Okay, hopefully you have understand. You have looked on this kind of figures previously. Sorry, there's been a interruption. Sorry, just wait for a minute. Yeah. Okay, so this is O, this is A, this is B. This is right angle triangle for you. This side is hypotenuse, this is perpendicular, and this is base. This is F, this is Fy, and this is Fx. Okay, so in order to understand the derivation that I'm showing you, you have to keep in mind this figure. Okay, so I would advise you before looking on to this lecture video, when you come to this slide, just pause the video and draw this image onto your paper. So when I'm talking about the derivation of it, so you can again refer to this figure. Okay, this will help you a lot. Okay, now let's move forward. We have come to this part. Okay, Fx is equal to F cos theta. Now we are talking about similarly sine theta is equal to perpendicular upon hypotenuse. You have to remember the formula. Its formula is sine theta is equal to perpendicular upon hypotenuse. So the perpendicular side is Fy. You can look onto the figure, and the hypotenuse is F. So Fy is equal to F sine theta. Okay, this is it. Here you have to done. You have to do till this part, and here what I have done, I have resolved a force into its perpendicular component, which is Fx and Fy, and we have derived a formula, which is previously Fx is equal to F cos theta and Fy is equal to F sine theta. Okay, so this is it for this lecture video. Now one last thing I want to tell you, that in order to remember this formula, I'm writing something for you. What I have said is sine theta is what? Sine theta is equal to what? Perpendicular, I am showing it by capital P, and hypotenuse, I am showing it by H. Okay, so sine theta is equal to perpendicular upon hypotenuse. And what is cos theta? Cos theta is equal to base upon hypotenuse. Okay, this is base, which I am representing by B, upon H. So there is one technique that has been used worldwide, to remember this formula. You could remember it like this: some people have curly brown hair. Okay, some people have curly brown hair. So in order to understand to remember the formula of sine theta, you have to remember some people have. How the first letter of S is sine theta. The first letter of sine theta is S. Okay, and the first letter of sum is S. Okay, so you can remember. You can remember like this. के sin theta के S से आप sum के S को याद रखें, people के P से आप perpendicular के P को याद कर लें, और hypotenuse के half के H से आप half को याद कर लें, तो ये हो जाएगा sum people have. Okay, for curly brown hair, cos theta का C, brown का B यानी base का B, और hypotenuse का H, तो curly brown hair. Okay, so this is one technique which normally a lot of people, not just in Pakistan, outside Pakistan also used to remember this formula. Some people have curly brown hair. Okay, so this is it for this lecture video. Hope you have understood this lecture. So we will meet very soon, inshallah, in the next lecture video. So till then, I have to say goodbye to you. Okay, so goodbye.